The following webinar is presented by the E-Extension Farm Energy Community of Practice at extension.org and the University of Nebraska Lincoln Extension.
We have a good speaker today. We have with us today Richard Nelson, formerly at Kansas State University, but now has a marketing and analysis business and also does some educational outreach with his business, InterSoil Resources.
This webinar today is going to be, like John said, a follow-on to what I did a month ago, but this is going to get a little more technical. Last month we did something on the renewable fuel standards, sustainability, things that were more of a high-level look at biodiesel, and today we're going to get down kind of in the weeds a little bit. Not something super technical, but make sure that you're aware of the production aspects and fuel quality, which is critical to this industry, especially with dealing with the renewable fuel standard. And I'm going to talk about best management practices, so some things you can take away to people as they ask you about implementing biodiesel or getting started in it. Then I'm going to wind up the presentation with a look at three separate areas for success stories, people that have used biodiesel successfully in their operations, and different aspects of that as far as size and the markets they look at. So, again, like John said, if you have a question, type it in the chat box. We'll definitely answer it at the end of the webinar, but if we think it's important as we go along, we'll take a stop and make sure we get that clarification there. So with that, I'm going to go ahead and get started. This on the screen is the actual accepted definition by the Environmental Protection Agency, by the Internal Revenue Service for biodiesel. It's fuel comprised monoalkyl esters, long-chain fatty acids derived from vegetable oils or animal fats. It's designated B100 and meets the requirements of ASTM B6751. And I'll talk more in detail about the ASTM specification for this as we go on. In January, I think it was January 31st of 2013, the IRS, the blender's tax credit went back into place, and that says that if a blender, a petroleum distributor, takes biodiesel in the B100 form, that it can be blended with diesel fuel, and that person will, in effect, in a very high-level look here, it's a little more complicated than this, will receive $1 per gallon. That's called the blender's tax credit, and the IRS handles that because the business that's doing it actually gets that taken off of his excise tax credit, and that's as far as I want to get into the details with this. But this is the actual definition. So biodiesel can be made from any fat, oil, or grease, or combination thereof, but this definition goes to that, and it has to meet this particular definition. I've got a question real quickly from Dennis. It says, can small-scale producers receive the $1 per gallon credit? Yes, they can. Anybody that blends the biodiesel can receive the $1 per gallon. But the feedstocks that you use have to qualify through the RFS as well. I talked about ASTM. This is the American Society of Testing and Materials. This is the ASTM role in the United States. They do standards, and like I've done that second bullet there, they've got over 3,300 ASTM standards that are cited in the Code of the Federal Register for different types of materials. And I was actually doing some work before I got into this webinar this morning. I was using one of these Sharpie highlight pens, and at the bottom it says that this pen conforms to ASTM D4236. So your highlight pen has an ASTM specification with it. The reason why, back in 1994 roughly, the biodiesel industry, and I'll show this in another couple of slides, biodiesel is not super hard to make. It's a lot easier to make than, say, making ethanol from cellulose. It's a lot less chemically complicated from a chemical engineering standpoint. So we realized that people could make this fuel, but this fuel has to be able to work in a compression ignition engine, in a diesel engine, and it can't screw up the engine. So the National Biodiesel Board at that time went to ASTM and said, look, we need a standard for the biodiesel, something that it can always make. We need it feedstock neutral, so when it comes out, it's performance-based. So that's why I went to ASTM, and I will talk later a little bit about why we don't use an international standard for this. There are some complications that go between, especially between us and the Europeans, on how you look at the fuel quality aspects of biodiesel. And we're close, but there's some other things there. So Again, ASTM, number one cited standards development organization in the world. We will continue to use ASTM standards for fuels. And now the fuel to be qualified as biodiesel has to meet the ASTM standard of B6751. And there are actually 4 different standards for biodiesel use in the marketplace as it exists now. The ASTM B6751 is for the B100. If Richard Nelson Biodiesel Company makes the fuel and it's in barrels or goes into rail cars or trucks, at that point it has to meet the ASTM specification for that. And I'll show the 20 parameters later. I'm not going to go through every one individually, but I'll show them. There is an ASTM D975, which is actually the diesel fuel specification in the United States. So if you get diesel fuel at a service station that comes from Valero or ConocoPhillips, that diesel fuel needs to meet the D975. But we found out that by putting a blend of 5% by volume into that, the properties were similar enough that it could be called D975. So you could, and people are receiving diesel fuel now that can have up to 5% by volume in that fuel, and it has to meet the D975 specification. That has less parameters than the D6751. About 2 or 3 years ago, maybe 4, something like that, the industry, the OEMs, the equipment manufacturers, this is people like the Fords and the Cummins and the Caterpillars and General Motors and Detroit Diesels, went to the National Biodiesel Board and said, look, we're seeing a lot of stuff above D5. B20 is kind of the cutoff here for our warranties. We haven't done a lot of testing. A lot of testing has not been done in the real world. We need a specification for that as well. So they came up with the ASTM B7467 specification. So if somebody is using a B10 blend that's 10% biodiesel by volume, boom, then they have a specification for that the fuel has to meet in that engine. Lastly, and I'll talk about this at the end as well, there's a specification for fuels that are used in the residential heating oil market, and this is primarily up in the northeastern part of the country, Massachusetts, New Hampshire, Vermont, where it's cold, some in the northwest as well. And that's trademarked as bioheat. That's up to 5% by volume, can go into fuels that meet the D396 specification, and is trademarked as bioheat. These are all performance-based standards. It has nothing to do with the feedstock necessarily. It has nothing to do with energy security, environmental. At the end, the ASTM specifications are a group of chemical and physical parameters that put together ensure that fuel will run in a compression ignition engine, with the exception of ASTM D396, and that's for open flame burners that are used with residential oil heat, like I said, up in the northeast part of the country. Okay, I talked about this in the last webinar, but I'll go real quickly. These are the biodiesel feedstocks that are most common on the left. Soybean is the major market share, running about 45 to 50%, depending on what time of the year it is and the number of instances. Corn oil, canola, camelina now is an approved feedstock, algae as well. And you've got your animal fats and your used cooking oils. Cottonseed, sunflower, and palm oil are not RFS2 approved feedstocks, and that means that they are greenhouse gas emissions, or life cycle greenhouse gas emissions, have not been approved by the EPA versus the conventional diesel fuel. They don't meet the 50% less than the conventional diesel fuel. People are working on those. I think they will get approved in the future. I'm not sure sunflower will ever make it. It just has too much value. It's too high priced as an edible oil. But the other ones are approved by the EPA. And I want to point out this high free fatty acid. And if you think about this, if you have something that's, I talk about pork lard, if you take that in your kitchen and let's say it's liquid, you've heated it up, and you go sit down on your front porch in the winter, it's going to gel up pretty quickly. And that's due to the high free fatty acid. Ditto for beef tallow and some of the used cooking oils as well. And that makes a huge difference if you go over to the right in the cold flow properties of the fuel and cetane number, which is the efficiency of the fuel within a compression ignition system. So each biodiesel feedstock does vary by its free fatty acid content, its chemical formula, and the different proportions. And this is as high as the chemical. This is outside my pay grade now to do this, but it does make a difference. There are a lot of places now, for example, that you would not use beef tallow or pork lard, for example, up in the northeastern part of the country, or northern part of the country for that matter, in the wintertime. They'll either cut the volume down, cut it with number one fuel, or they'll try to get more of the soybean and the canola type oils. So there is a big difference on how that works. Here is the simple version. If you go to Google Images, and I almost put this on here, and you type in transesterification, because that's what this is, it basically says 100 pounds of triglyceride, this is the fat, oil, or grease. You got 10 pounds of alcohol, 1 pound of a catalyst that goes in there. An output will get 10 pounds of glycerin and 100 pounds of this monoalkyl ester. That's that word again, monoalkyl ester. That's your biodiesel. So it looks pretty simple. You know, you put this stuff in a deal in your garage, and you mix it up, and away you go. Well, it doesn't quite work like that. So it looks good in a PowerPoint slide, but in reality, this is what happens here. This is the real world, and this can even get a little more complicated than this. And I'm not going to go through every one of these boxes, but down in the left-hand corner in the green square is, you talk about palm oil, soybean oil, canola oil, very, 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 very low free fatty acids. They just basically go into a drying field. They go right up into that box right in the middle of this transesterification, and away you go. It's almost like the slide before. Where you get into trouble, or people can get into trouble, is up here where it's in the red oval, the red dashed oval, where you have these high free fatty acid feedstocks. They've got to go through a whole other process before they get to the transesterification. And a lot of people did not realize that. And what that basically does in general is it strips off these free fatty acids and it goes through. So if you don't do it properly, this is what you wind up. That is an actual fuel filter that was pulled out of an engine, compression ignition engine, I don't know which one it was, and you can see the gunk that went through that. And that thing obviously clogged up within minutes. And that's because they got biodiesel that didn't meet the ASTM specification, that didn't know how to take out the free fatty acids. So it's a little more complicated. In fact, it can be a lot more complicated than just the simple slide I showed before. I got a question here from Dennis I'm going to take real quickly because it goes back to the last slide. It says, the soybean oil off-spec food grade? No, it doesn't have to be. It can be to some degree. You can also use food grade soybeans, and he says it's not how can it be economical to produce biodiesel. It depends on that market and what that market is. If you have a glut of soybean oil, whether it's food grade or not, on the market, but it also goes back to the blender's tax credit and to the RFS2 and the cost of RIN, or the price of RINs that are being to help lower the cost of biodiesel. So if you're making biodiesel for, let's say you're making it for $4.50, and the RIN cost for biodiesel is $1.25, then you technically could get rid of that, if my math's right, for $3.25 plus the blender's tax credit at $1, which probably doesn't work out quite like that because some of that's got to be kept in-house to do the accounting and the overhead. That's how you make it economically right now. And depending on what the cost is, you can, and what feedstocks you use. A lot of the people that are making biodiesel right now in the United States do not use just one feedstock. They go out, and it's a commodity, and they will buy and mix and match. So you might get a biodiesel that is 60% soybean oil and 40% restaurant grease from Mickey D's. And the next day they may make it on the exact opposite, maybe 60% restaurant grease and 40%. It all depends on the cost because they want to lower that cost, obviously, as much as possible. Karen Miller here has a question, says, if you use waste oil, what concerns should you have? The cleanliness of it? What is the makeup of that? What kind of, did they use pork lard? Did they use animal fat? Some combination thereof. If you can get it from a constant source, then you would have that probably tested up front before you made biodiesel, so you would know what the free fatty acid content would be and what the chemical composition of it would be before you go into your process. More than likely, and I'll say this to everybody, the slide you see in front of you with this, that's what most of the companies, if not all of them, are using right now. Again, because they're going to take the lowest cost feedstocks they can come up with. So, okay, ASTM current status. What we look at in the biodiesel industry is we look at this ASTM D6751. That is the specification for the B100 as a blend stock, but only up to B20. So if you use it in an engine up to B20, that's what you're going to be able to use, as long as the B100 that's made out of the plant meets all these physical and chemical properties. It's feedstock and process neutral. So we don't care what feedstock you use. We don't care how you make it. There are going to be variations on that previous slide of how people do things, and I've seen that in plants across the United States. we don't care. The industry obviously doesn't care because it's a performance-based standard with chemical and physical properties. Higher blends can be used, are being used in the industry now. We've got people using B40, B50. I've got people using B100 in underground mine. But you got to go to your OEM, to your engine manufacturer, and say, hey, I'm going to use this. Will it void the warranty? And if it still meets the ASTM specification, more than likely it will not. Now, here's why we use ASTM. The European specifications for B100 come from their EN 214, and that specification that is not feedstock neutral. They make a majority of their fuel over there for a long time off of rapeseed, a derivative of canola. So this is why D6751 is going to be different in some areas. But the bottom line is that the biodiesel meets this specification. It can be blended with diesel fuel up to 20%, and it's not necessary to analyze that finished blend if the B100 is okay. So if the diesel fuel meets the 975, the biodiesel meets the D6751, and you blend them together, it's 2 plus 2 equals 4. You're good to go with that. We will stick with the ASTM specification because there are some slight differences between the European specs. It's not much. It's in a stability requirement for the most part on how they view if the fuel sits out for a long time and isn't used, when would that fuel essentially go bad? In other words, if you think about putting an oil out in the middle of the summer, when's it going to go rancid? It's kind of the same type of look with respect to that. ASTM improvements. Lately, we have taken a number one called a B grade, a B100. A lot of times in the winter, people will use biodiesel at a 10% blend, or they used to use it at a 20% blend, and they, instead of using 80% number 2 diesel, they would use maybe 60% number 2 diesel, and the remaining 20% would be number 1. Kerosene is what it is. And well, people would cut their fuel in the winter with kerosene because it has excellent cold flow properties. It's jet fuel. It's derivative jet fuel. So this was a huge thing for the industry because we were seeing some filter clogging in the northeastern part of the United States above, or the northern part of the United States above the cloud point. Couldn't figure out what it was, so we came back with ASTM, got it to put together a new specification. So just wanted to make sure that you're aware of that. This is one thing about the biodiesel industry I do like is when we see a problem, we try to figure out what it is, and then if we need to go get a new spec, we do get a new spec. So just some quick information for you. This will also go in to the D6751 specification. Okay, again, feedstock and fuel quality. I can't hit this enough. Vegetable oils, animal fats, used oils, you're going to get a combination thereof every day. Very, very few people will use a single feedstock day in, day out, unless they can get that feedstock for a very, very low amount of money. The production skill of the people, not the feedstock, does determine the biodiesel quality. Again, we are feedstock neutral here. We don't really care about which one you use. We want you to use, obviously, one that's the most economical for you. But the feedstock, you need to know what that is because it affects the cloud point, again, the cetane number, and the density and the viscosity. And I don't want to get into the chemistry of carbon chain distribution on the thing, but again, it's pretty obvious if you have something that's like animal fat, pork lard, or that kind of deal, you're going to have a higher free fatty acid. That stuff's going to gel up quicker. It's going to be above the cloud point of those diesel fuels, which I'll talk about later. Here is the actual specification. And I've got the website here if you want some more information on it. But what I want to talk about here real quickly is on the left-hand side of those properties, there are 20 different properties, if I did my math right this morning and counted correctly. The ones in bold go to a program called BQ9000 that I'll mention here in a minute, that talks about the quality aspects of biodiesel all the way through the supply chain. But you can see you've got these different properties. You've got an ASTM method. You've got the number 1 B, the number 2 biodiesel there, and then the units that go with it. These properties all have to be met on every load that comes out of a plant to qualify for the ASTM D6751 specification. The ones that are bold, again, are only to the critical components with BQ9000, and the easiest way to explain this is you flip it over and say, if you don't meet this critical component for, let's say it's the cloud point down there in the middle of the page, then there's no sets and testing for the copper strip corrosion 2 lines above it, because you're out. You have to meet all 20. It's an all or nothing. There's not, I'm at 19 of them, and they all were great. 20 of them, not so much, you're out. You've got to meet all of them, or the engines will not be warranted to that specification. Here is the one for D7467. You can see there are a lot less properties. because at that point there, most of them have already been met through either the diesel fuel specification or through D6751. But these, again, have the bold for the BQ 9000 specification. So these are the two main ASTM specifications for biodiesel, and the properties that have to be met. Then they test those on loads that come out. Most of the places now have their own in-house lab. They'll take samples. They'll run those there before they put it into the truck, before they put it into the rail car. So if they ship it off to John Hay petroleum distributorship, he knows he'll get a bill of lading. He'll get a product transfer document, and that will say this biodiesel met this specification. And more than likely what it will do, and I know what it will do, it will give all the properties for the ASTM specification if he receives a load of B100. And it'll say, here's the limit on that. I'll go back real quickly. It'll have the limit there that will be either number 1B or number 2B. And let's take the column number 2B. It'll have that limit, and then the column over to the right of that will say, here's what the limit, what the actual number was for that particular load. That's the way it'll be doing. And that's the way everybody should accept it as well. We'll talk a little bit about BQ 9000. This is a program that was put in place about 6 or 7 years ago by the National Biodiesel Board. And you can make the fuel at the plant and make it meet ASTM quality. And most of the fuels that do make it now meet and beat the ASTM specifications, so they're good to go. What we were seeing in the industry was as that fuel got transferred downstream to, again, Richard Nelson makes it, hands it to John Hay, he sends it out to somebody else in the industry, he gives them a blend, and then they put it in there. There are things that can happen. Maybe that tanker truck didn't get cleaned out properly. Maybe it had a load of milk in it beforehand and someone decided to put biodiesel in there. Or the tanks at the service station were not cleaned out properly. So the BQ 9000 is a supply chain management program that says from the time it is made at the plant to the time it goes into that final use, and that includes pumping it out of the final tank into the vehicle, all things have been taken into consideration. The lines have been cleaned out properly. The tanks have been cleaned out. The lines have been insulated properly. So where the ASTM, where it meets it at the production, it now meets it at the final end use. So there are 3 designations here. There's a producer. There's a marketer. This would be someone that would be a petroleum distributor, for example, that doesn't make the biodiesel, but is going to accept B100, blend it into a B20 for person A, B5 to person B, and B10 to person C, or someone like that. And then there's a laboratory that says that they can actually do this. They can do their actual testing to make sure that it meets all the ASTM specifications. Right now, about 85% of the total volume in the United States comes from BQ 9000 plants, and that's because a lot of the OEMs not only specify ASTM D6751 fuel, they specify, for example, that it has to be produced from a BQ 9000 plant. For example, the New York City Department of Sanitation runs B5 in the winter, they run B20 in the summer, and all of their biodiesel has to come from a BQ 9000 certified plant. So that's why we did it, to instill some confidence in the market there, not only with the people that are using, but the engine manufacturers as well. If you want to learn more information, go to that website. But it was modeled after the old ISO 9000 program. Real quickly, excuse me, their fuel filters and solvency. Pure B100 it's a solvent. It's going to clean out a tank like crazy. We don't see this so much at the B2 to B5 level. There's some people that are saying that it does happen. Your tank must have been really, really dirty and should have been cleaned out before this. But diesel fuel in a tank left untouched for a long period of time, or if that tank had constantly used diesel for the last 5, 10, 15, 20 years, will have a lot of sediment and dirt built up in it. This stuff's a solvent. It'll clean out that tank, so just be aware of that. The B20 level, it can run stuff through the system, and it will clog your fuel filter without a doubt. But in some places at the higher blend level, say B10 to B20, be aware that that can happen. You might want to have an extra box of fuel filters around. But at the end, even though it'll cost you a little bit more to have some fuel filters and change them out, your engine will run more efficiently because you're not running that stuff through your system. So just be aware that it is a fuel filter thing. I always tell people when they get into it, I wouldn't start with a B20 blend. I start with B5 and work my way up, maybe a B20 or B10, and then go to a B15 or B20. Get that stuff out to your system, and then things will be a lot better after that. Just an operational standpoint there. One of the major things about is the cold weather, and basically, again, this is where you need to know the biodiesel. You need to know what the cloud point is. And one thing I did not point out on that ASTM D6751 sheet of the 20 parameters. Cloud point is one of them, but you have to report that. There is no set cloud point in that specification, because in Houston, Texas, the cloud point can be a certain value, and then in Duluth, Minnesota, it can be something completely different. So we have kind of a fit-for-purpose fuel, and we have people in Houston, Texas that make a fuel down there that can have a different cloud point than the rest of the United States, because they're only going to use it in Houston. It's warm down there. Rarely do they get below freezing down there, in the sense of that would affect the tanks that are underground and whatnot. So they can use a lot more lard, tallow, and waste grease-based fuels than you can in some place like Minneapolis or Duluth, Minnesota. So this stuff's going to freeze up a little faster. Untreated is going to freeze about 2 to 10 degrees faster. So whatever I do, I take the cloud point of the diesel fuel, whatever it is, and I add about 5 degrees up from that, and that's where this stuff's going to start to cloud up. So if the cloud point of diesel is 35, then this stuff, you're going for a cloud point of about 40 degrees in general. The more high free fatty acid fuels you use, the higher that cloud point can be, and you need to be aware of that. Most petroleum distributors know how to handle that. They just need to be educated a little bit on the biodiesel side of it to look out. Look a little bit above that level. 5 to 10 degrees would be ample. Okay, this is kind of the boiled down slide here to maintaining biodiesel fuel quality throughout the system. If you're going to get into this, or you have a client or someone's asking about, hey, I want to get into biodiesel, I want to start producing this, or I want to start using it, check the producer with the National Biodiesel Board. Call us up. We will be glad to check them out. And we have checked people out. Fly-by-night biodiesel isn't going to work. You know, these guys, we've had people get into this business. They don't know what they're doing. They will not use the production system I showed earlier, and they'll run a bunch of free fatty acid fuel through this, and they'll wind up with terrible fuel. And we've seen that with these fuel filters that'll clog up, like I showed before. As you go downstream where the transport tanks clean properly, do you need heated tanks? A lot of the fuel made in the United States comes from Iowa, comes from Texas. If you're transferring fuel in Texas, you probably don't need a heated tank. But if you're transferring fuel from the Gulf Coast, where it's made maybe cheaply, and you transfer that stuff up to Nebraska, Kansas, Iowa, up in the Dakotas, someplace north, you're probably going to need a heated fuel tank. Are those heated tanks necessary? They're probably going to be. Once it gets on site, you just clean out the tanks properly, or the support personnel properly educated about this. This only takes about an hour to educate people properly about bio and the bio blends and whatnot, and was it blended properly. We've got people now that they do a lot of splash blending, where the diesel fuel will go into the tank first, you put the biodiesel on it second. As that tanker truck goes up and down the road and hits a few potholes and turns left, turns right, stops, it'll mix it up. We don't like that, but that's the way it goes. And then lastly, what's the length of the storage on site? And do the above-ground tanks and fuel lines need insulation for winter? Are they painted white for reflectivity in the summertime? Is that tank going to be exposed to the sunlight? Just minor things as well. And right below that blue arrow up in the top left-hand part there, I kind of skipped over that. Every time you get a load of fuel, you should have that certificate of analysis with you, because if you put that into a system and something happens, you can be in real trouble with the engine manufacturer, and you need to go back and say, hey, this load they said it met the ASTM specification, and keep a sample of that, and that way you have something. That's your legal protection going back. So again, this slide is just to boil down the critical points to maintaining the biodiesel fuel quality all throughout the system. BQ 9000 does this. This is what BQ 9000 was set up to do. So all these critical little nodes and points here, then there's a place where there's a check-off box to say, hey, it met the quality at this particular point. We used to see that quite a bit in the industry. We don't see it hardly that much anymore at all. BQ 9000 has really cleaned up the industry. Okay, I'm going to talk about 3 biodiesel fuel success stories real quickly here. You can use these. Out of Arlington County, Virginia, they run about 500 vehicles per year. You can see they're Class 1 to Class 8 trucks, so they run small stuff, they run large stuff. Fire trucks they're running, and construction equipment, a lot of school buses and some other buses as well. But they use, as you can see there, about 600,000 gallons in their fiscal year 2011, and it varies across the board. You can see what they've used from 2005 to 2011. They use a lot of biodiesel. They've used it for about 10 years plus. Winter months, they do use B5, B20 the rest of the year. So about 3 months in the winter, they'll get down to B5 just for cold flow reasons. And the reasons why they chose it were they wanted emission reductions. They were kind of starting to get mandated a little bit about that. They did want to reduce fossil fuel, but there was the ease of implementation. There are other alternate fuels you can go with: propane, natural gas, ethanol, all different kinds of things. One thing about biodiesel, it's a pour and go. If you handle it properly with the storage tanks and the blending, it's a pour and go. It was a seamless operation for them. So when I talked to Alan Mitchell, this is what he provided to me. And one thing I like about this is he's got a lot of different vehicles. The last thing you want is to have a school bus full of kids at 7:30 in the morning being stopped for cold flow where your filters have clogged up because of the free fatty acid content of the biodiesel. He says he's never seen that. So good quality fuel is what he gets. He checks the bill of lading every time and makes sure that the biodiesel that he gets meets the ASTM specifications. Here's Cincinnati Metro that has run biodiesel off for a number of years. They were one of the first metro urban bus companies to do this, and they ran it in their 340. They ran blends, again, you see their B5 to B99, depending on price and availability. Again, you can see after Katrina hit in 2005, they switched to B99, but they stuck with the B20 in the winter. They were all about a green mission. They wanted to generate some positive press for themselves. And there are other ones. I was leading a project in Kansas City where we used the metro system there, and we ran tallow-based B20, and we run soybean-based B20 in these buses as well, and not had a problem with it at all. We did our upfront homework. The bus companies did their upfront homework as well and got those tanks cleaned out. But St. Louis has run it, San Francisco, many others have done this as well. It's good for the urban environment because the emissions are so much less than conventional diesel fuel. And the last one here on the BioHeat, this again is what I'm talking about. The northeastern part of the country in I think it's 7 northeastern states up there, use on average between 3.5 and 4.5 billion gallons a year of residential heating oil. So they run into, and the average there you see was 4.3 billion gallons in 2007, 2011. But a lot of the places up there that used to deliver 100% residential heating oil are now using a B5 blend. And I'm going to look at T.H. Malloy. They've been distributing biodiesel for 8 years now. Over 4,000 customers receive a B5. That's what the D396, ASTM D396 specification is, only up for B5. We've got other people listed there, Tevis, Guardian, and Cohen, all use it up there in the northeastern part of the country, and people love it. They love the smell of it. They love the fact that they're using a renewable resource. But this is a huge market at 4.3 billion gallons per year. So this is another thing that people don't really know a lot about. It's not a transportation application. It's not an underground mining or a school bus or a long-haul fleet. It's something that goes in people's houses. I was up in Boston a couple days ago, and you could see a lot of the tanks that were sitting outside. The guy I was with saying, this is what we service with our BioHeat. So a big market, a new market, an interesting market for the bioindustry, biodiesel market. Last couple slides here, Biodiesel Handling and Use Guideline. This is called the HUG. This is published by National Renewable Energy Lab. It's about, if I remember right, 80 pages long. But I give this out to anybody that wants to get started. It talks about how to handling. It talks about feedstocks. It talks about cold flow, stability, everything somebody needs to know if they're going to get into this business. And like I said, it's 80 pages long, but if you want to be serious about it and want to have a successful operation, this is something that needs to be taken under consideration. So a lot of what I've talked about today, in fact, everything I've talked about today, is contained in this Biodiesel Handling and Use Guideline. And you can find that at the biodiesel.org's website, or go there to the National Renewable Energy Lab. It was last published about 2009, if I remember, but everything's still applicable to it as well. Lastly, got biodiesel resources here. So if you want to go, there's a lot on the biodiesel.org. If you have questions, call that telephone number, and we will get people to you that answer your question. I may not be able to answer it. Someone else on the more technical side for sustainability may be able to do that. But we get a lot of email requests and a lot of telephone requests from people out in the world. So feel free to call.
This webinar has been brought to you by the Farm Energy Community of Practice and the University of Nebraska-Lincoln Extension. For more information, go to farmenergymedia.extension.org.